Okay, this is going to be part 2 of the series on how to change a repeating decimal into a fraction. And if you haven't done it yet, I would definitely watch part 1 because it'll show you the techniques that we've used so far. And we'll use exactly those same techniques in this video. Now to start with, the difference between the first video and this video is that in this video, you'll have a repeating decimal, but the entire decimal doesn't repeat. Like in this case, you've got 0.53 is not going to repeat, but the 7 will be the repeating part. So to solve this, we'll do exactly the same steps that we did in the last video. Let's take a quick look at those. Step number 1 will be to change the repeating decimal into a geometric series. Then when you've got the geometric series, you can use the formula for the sum to find the sum of the geometric series and express that as a fraction, and you'll have your answer. And again, just to remind you from the first video, the form of a geometric series looks like this. It has some initial term, and then the other terms are some common ratio raised to the n power. So you'll need the initial term and the common ratio. And then the formula for the sum of a geometric series, if it's an infinite series and it converges, then the sum would be equal to the first term divided by 1 minus the common ratio. So we'll take advantage of those as we work through this. Okay, with that in mind, let's take a look at our first problem then. And the first one looks like this. You've got 0.53, and the 7 repeats, but the 0.53 doesn't. So we'll still use our steps. First step, change the repeating decimal into a geometric series, exactly like we did it in the first video, with one minor exception. Now, first of all, I'm going to rewrite it, and I'll rewrite it as 0.53. Now, that's the non-repeating part. Then, just to emphasize the difference, I'm going to change color here. We'll go times 7, times 7, times 7, times 7, repeated infinitely far. Now, what we'll do is, just like we did last time, we'll break it down vertically and then put it together horizontally. So what will happen is, first of all, the first thing you'll do is bring down this non-repeating part. So that gives me 0.53. Then I'm going to add to that, so just like I did before, I'll now take this number and bring it down. And that's going to give me 0.007. And then I'll add to that, I'll take this one and bring it down. And that gives me 0.0007. Then finally, I'll bring this next one down. Just keep bringing them down. And this will give you 0.00007. And you would keep doing it. So if you broke it down into individual terms, the first one, the non-repeating part is the 0.053. And then this term would be 0.007, exactly like we did in the last video. So you just keep bringing them all down. Now what we'll do is change them from a vertical form here into a horizontal form, but I'm still going to keep that non-repeating part in a red color just because it's going to be treated a little specially. So I've got 0.53 is the first term. Then the next term would be 0.007, and the next term would be 0.0007, and the next term 0.00007, etc., and it would go ahead and repeat forever. So what that is, that's the decimal expressed as a series. Now, the thing that's a little bit different about this is when you form the geometric series is only going to be formed from the repeating part. So in effect, we can kind of do this. Like I'll just go ahead and put a line that goes from here, say, down to here. And we'll actually split the problem into two parts. This is going to be the non-repeating part. This is going to be the repeating part. And then we'll treat each one as a separate column and then combine the results down here at the bottom. So let's take a look and see what that's going to look like. Now on this first one, again, just like we did in the last video, we want to find the summation of a sub 0, and then this is going to be r raised to the n power as n goes from 0 to infinity. And right away, you know the first term, and the first term is going to be this right here. This would be a sub 0. Now to find the common ratio, just like we did in the last video, take the second term and divide it by the first term. So 0.0007 divided by 0.007 will give you 0.1, and that's going to be the common ratio. So now you know the ratio. And again, we'll just sort of express that. What that is, if you take the first term and multiply it times 0.1, you'll get the second term. If you take the second term and multiply it times 0.1, you'll get a third term, and so on. So you know the initial term, and you know the common ratio. So now we'll rewrite that right here. This will be the summation as n goes from 0 to infinity. First term is 0.007, and the common ratio is 0.1 raised to the n power. So what this is, I have now expressed the repeating part of this decimal as a geometric series. Now what I'd like to do is to find that sum. So the sum of just the blue part of the series, and again I'll go back and check my formula. Again, sum, it's the first term divided by 1 minus the common ratio. So what that's going to give me would be a sub 0 divided by 1 minus r. Well, in this case, a sub 0 is 0.007. Then I've got 1 minus the common ratio of 0.1. So that gives me 0.007 divided by 0.9. Now, I want to get rid of the decimals in this fraction, and to eliminate the decimal in the numerator, I'd have to move the decimal point 3 places to the right. So I'm going to multiply the top number by 1,000. And whatever I do to the top, I've got to do the same thing to the bottom, and I'm just trying to get rid of those decimals. So it will move this one 3 places to the right and give me a 7. It will move this one 3 places to the right and give me 900. So what this is, this thing right here, is the sum of all of these blue 7s, just the repeating part of the decimal. But I do not have yet the 0.53. So this is where the second part of the problem is going to come in. So we'll take this, and again, we'll go from here and just extend this down just a little bit. And now the idea is to do this, is to take this one, change it into a fraction, and then combine it with this one. So you'll put the two parts together. So let's go ahead and just bring this one straight down. And that's going to be, and I'll rewrite that as 53 over 100. And I'm going to add this to this answer right here, which was 7 over 900. So the idea is that the non-repeating part of the decimal turns out to be 53 over 100. The repeating part turns out to be 7 over 900. And now it's just a matter of putting those two together. Well, since this one's over 900 and this one's over 100, I'll multiply this one by 9 over 9. Get them over a common denominator. And when you do that, 53 times 9 turns out to be 477 divided by 900 plus 7 divided by 900. So what you're adding is, this is the non-repeating part of the answer, and this is the repeating part of the answer. And then add the two of them together. So 477 plus 7 would give a 484 over 900. And that's going to be the entire decimal expressed as a fraction. But sometimes you can simplify these, and this one actually will simplify. So it'll simplify down to 121 over 225. So that's going to be the final answer. So really the only difference between these two, if you've got part of the decimal that does not repeat, just treat it as a separate problem. Then set up the repeating part as a geometric series, find the sum of the repeating part, then change the non-repeating part into a fraction, add the two fractions together, and you've got a final answer. So it just adds one more step. And we'll do one more of these. This one didn't have a leading integer in front, so let's try one additional example just to make sure. Okay, now in this one we're going to do exactly the same thing, kind of go back to our steps again. And the steps will be, first of all, change the repeating decimal into a geometric series. And again, only the repeating part of it. And then we'll find the sum of the geometric series. So it'll look like this, and we'll follow exactly the same process. First of all, I will rewrite this as 2.51. And then the 3, 7 repeats, so I'm going to change colors just to emphasize that that thing repeats. So then I've got 3, 7, 3, 7, 3, 7, and it goes on forever. Now again, I like to write them down vertically first. So the first thing I'm going to do is take the non-repeating part and just bring it straight down. So I've got 2.51. And then I'm going to add to that each of these repeating parts. So I'll take the 0.37 and bring that down. And that gives me 0. I'll have 0.0037. Then I'll take the second one and bring it down and add those together. That's going to give me 0.000037 and so on. Then you can take the third one, bring it down, and you can just repeat the process. Now, just like we did in the last video, we'll go ahead and change it from this vertical form. We'll change it into a horizontal form. So, first of all, I'm going to take the 2.51. We'll go ahead and put it right here. So 2.51. Whoops. 1. Let's change that to a 1. 2.51. Then I'm going to add to that the repeating parts. So I've got plus. This first one would be 0.0037. So 0037. The second one would be 0.000037. And then plus, the next one would be 6 zeros and a 37, and so on. Now again, we'll do it exactly like we did in the last problem. You've got a non-repeating part of the problem, and you've got a repeating part of the problem. So the idea is to just change the repeating part of the problem into a geometric series, and then treat the non-repeating part separately, put the two together at the end. So we'll do it kind of like we did the last time. It's almost like you'd start right here and just put a dividing line most of the way down the page and treat them as two separate problems. So let's begin by this one exactly like what we've done in the past. I'm going to try to change it into a series. So this is going to be from n equals 0 to infinity of the first term of the series times the ratio raised to the n power. Now the first term of the series is easy to get. It's always whatever that first term is right there. That's a sub 0. And again, to get the ratio, same thing we've done before. Divide the second term by the first term and you'll have it. So 0.00037 divided by 0.0037. And when you do that, you'll get 0.01, and that's going to be the common ratio. And again, what this is would be if you take the first term and multiply it times 0.01, you get the second term. If you take the second term and multiply it times 0.01, you get the third term, and so on. So now we can rewrite this as the following. It's the summation from n equals 0 to infinity of the first term, which is 0.0037, times the common ratio, which I now know is 0.01, all raised to the n power. So what this is the repeating part of the decimal expressed as a geometric series. Now you can find the sum of this blue part, of the repeating part. So we'll do that, and again, using the same formula, the sum. And again, the formula looks like this. It's just first term divided by 1 minus the common ratio. So this would be the first term would be well, we'll just write up here first of all, a sub 0 divided by 1 minus r. So a sub 0 is 0.0037 divided by 1 minus the common ratio, which is 0.01. So this is going to give you 0.0037 divided by 0.99. Okay, now the next thing I want to do is to get rid of the decimals. So in the top, I'm going to have to move the decimal point 4 places to the right. And whatever you do to the top, you got to do the same thing to the bottom. So I'll actually have to multiply this thing by 10,000. And multiply the bottom by 10,000. And what that does, that will move the decimal point 4 places to the right. So this will turn out to be 37. And when you move this one 4 places to the right, it would be 9900. And what this is the sum of the blue part, the repeating part, expressed as a fraction. But you're not quite done yet because you've still got this non-repeating part. So the idea is to go ahead and just bring the non-repeating part down, change it into a fraction, and then put the two parts together. So this thing right here I can express as 251 over 100. So this would be the same thing as 251 over 100. And I'm going to add that to this non-repeating part, which was 37 over 9,900. Now, this one's over 9,900, this one's over 100, so to put these together, you got to get them over a common denominator. So I'll multiply this one by 99 over 99, just to get them over a common denominator. And when you multiply that, this will turn out to be 24,849 over 9,900 plus this 37. So 37 over 9,900. And then finally add those together, and you would get 12,443 over 9,900. And that's going to be the entire decimal expressed as a fraction. Again, you can always check this. If you were to take this, put it on a calculator, and divide it by 9,900, you'll see that it really does turn into this. So again, the process on both of them is the same as if you have something that doesn't repeat, and we'll go ahead and look up here. So part of this thing does not repeat, and part of this thing does repeat. So really split it up into two separate problems. This is the non-repeating part, and then all of this over here is the repeating part. So just looking at the repeating part, change it into a series and find the sum of just the repeating part of the decimal. Then take the non-repeating part, bring it down, change it into a fraction, get them over a common denominator, put the two parts together, and you've got it. So that's how you treat problems that have part of the decimal repeats and part of the decimal doesn't repeat. And hopefully that'll help you out a little bit.